Okay, so to finish up this example, let's do some examples to pull it all together. So given the point P is negative 5, 1, and point R is 3, negative 2, we're going to write vector PR in component form, where you're going from P to R. So remember, the way you can easily do this is find the slope. So since I'm going P to R, P would be my 1s, and R's would be my 2s. So I do y2 minus y1 over x2 minus x1. So I get negative 3. Remember, a double negative turns into a positive, so over 8. And that's component form. So component form is the x, which is the run. Remember, run is x, so that's 8, comma the rise, which would be your y component, so negative 3. And remember, component form has those triangle brackets, okay? So to write vector PR in ij form, you take the 8 and put in front of an I, and you take the 3 and put in front of a j. So same thing as component form, but in unit vector form. Okay, to find the magnitude of PR, well, remember, magnitude is the absolute value of PR, but you don't just change that to 8, 3. That makes no sense. Okay, so to find the magnitude of PR, we are going to use the formula. So that's going to be the square root of the x component squared, so 8 squared, plus the y component squared. So 8 squared is 64, negative 3 squared is 9, so you could just type in what's underneath first. So I could do 8 squared plus negative 3 squared, and that's how you get square root of 73. Or if you really feel like it, you could actually type in what is the square root of 73. That's how I get 8.544. Which one you give us, we don't care. Okay. Let's see, then find the direction of PR. So this is where you have to do that whole reference thing. So think about PR. I got 8, negative 3. So here's 8, here's negative 3. We're assuming that we're starting at 0, 0 to 8, negative 3. So that's how I find out that I'm in quadrant 4. Okay. So if I'm in quadrant 4, I'm going to do 360 minus, so I'm just using this here, the reference angle. To find the reference angle, you're going to do tan inverse of the y component divided by the x component, but you want the absolute value of that. So it'd be positive 3 over positive 8. So if I type that in, 360 minus tan inverse of 3/8 is how I get 339.444 degrees. So remember, inside, it must be positive if you're going to use the reference angle technique. Okay. Okay, so they want to know, does the magnitude and direction change for going from R to P? So if you go R to P, that means you're going to do x1, y1 for R and x2, y2 for P. So let's see how that changes my vector. So if I do y2 minus y1 over x2 minus x1, well, 1 minus negative 2 is positive 3, and negative 5 minus 3 is negative 8. So all that's happened here is I've changed the direction, which means my signs change. Okay? So let's check magnitude. So if I want to do the magnitude of vector RP, I do the square root of the x component squared plus the y component squared. If I type that off to the side, I get square root of 73 again. So the magnitude stays the same. The magnitude stays the same. So if we change the direction of our vector, the magnitude stays the same. Well, let's check the direction angle. So now instead of going to 8, negative 3, we go to negative 8, positive 3 from 0, 0, which is in quadrant 2. So our angle is definitely going to change, right? If you're in quadrant 2, we would do 180 minus tan inverse of y over x, but do the absolute value. So positive 3 over positive 8. So 180 minus tan inverse of 3/8. And that's how I get 159.444. And that should make sense that the direction changes, because instead of going from P to R, if you're going to R to P, that's what's changing, is the direction you're traveling. Direction does change. So there's that. Okay, so let's go ahead and go to the last page, which is page 6. So page 6 is where we're going to finish this up, and it's just a few more examples. So on page 6, let's see. We're going to use the diagram to the, sorry, this is page 4. I keep saying page 6. Page 4, number 6. So we're going to use the diagram to the right. So to the right, we have this nice little right triangle with vector v, okay, and then theta. Y is the distance you go up or down. X is the distance that you go left or right. And the magnitude of vector v is the length of this actual vector, okay? So using our definitions of sine and cosine, along with the diagram, we're going to find sine of theta and cosine theta. Remember that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, right? So sine theta would equal opposite, which is y, over the hypotenuse, which is the magnitude of vector v. And cosine theta is the adjacent side, which is x, over the hypotenuse, which is the magnitude of vector v. Okay. Using our equations from part B, we're going to complete this following statement. So we want to solve for x. Well, if you want to solve for x, just multiply both sides by the magnitude of vector v. So x would be the magnitude of vector v times cosine theta. And if I do the same thing to my sine equation, y would be the magnitude of vector v times sine of my theta. So if you know your theta and your magnitude, you actually can find the component form of your vector, because remember, all vectors are your x comma y components. So my x component would be the magnitude of vector v times cosine theta, and my y component would be the magnitude of vector v times sine of my theta. So to see how this works, if they want you to find the component form of vector AB, given that the direction, aka theta, is 120 degrees, and the magnitude, aka the absolute value of vector AB, is 6, we can easily find component form. Component form would just be the magnitude, which is 6, times cosine of that angle, and then comma 6 sine of that angle. Oops, not parentheses. Component form, so triangle bracket. Well, this is what I was talking about. 120 degrees, guys, is on the unit circle. We know what sine and cosine is at 120 degrees. So that's 120 degrees right there, okay? So remember, cosine, I'm going left short, so that'd be 6 times negative 1/2, and then 6 times up long, so positive √3 over 2. And if it's been a while since you've looked at these unit circle values, it's time to start reviewing those, okay, because your final is coming up. So let's see, 6 times negative 1/2 would be -3. And then 6 times √3 over 2, well, 6 divided by 2 is 3, and then you're just stuck with √3. So that would be your component form of number 7. Do not use decimals. I will tell you on your homework, it says something about exact answers. So make sure that you actually show this with 3√3. So we're going to do one more video just to cover number 8 and 9, and then I'll talk about your homework. So it will be a shorter video, but we do have to go into one more. So see you guys there.